Hello everyone, in this video we are going to learn about CPM, critical path method for project evaluation. The procedure is as follows. Step 1, construct the network. Step 2, forward pass computation for earliest event time. Step 3, backward pass computation to get latest allowable time. Step 4, identifying critical activities and joining them from beginning to the end of the network to get critical path. Step 5 is calculating project duration, and step 6 is calculating different floats. So now let us see this procedure with the help of an example. The question is as follows. A project schedule has the following characteristics. So the data is given in form of activity and the time duration of each activity. From the above information, we are required to construct the network and then compute the earliest event time and latest event time. And third one is determining the critical path and the total project duration. And the fourth one is you have to calculate all the different floats. So this is the question. So let's start with the solution. So this is the given data. So according to this data, we are supposed to construct the network now. So let's start with the first activity. So first activity lies between the nodes 1 and 2. For our convenience, I'll just name these activities. So I'll name this as A, I'll name this as B, C, D, E, F, G, H, I, J, K and L. So now I'm going to talk about the activity 1, which is between the nodes 1 and 2. So we'll start with the construction of the network. So we need 1 as the initial node of the network. From 1 we have an activity towards the node 2, and the activity is named as A, and what is its duration? It is 4. So activity is A and its duration is 4. So similarly, we have the next activity from 1 to 3. So 1 to the node 3. So the activity name is B and the duration is 1. So B 1. So this is done. Next, let us see 2 to 4. So we have the node here 2. So we have to add a new node which is numbered as 4, and its activity is C with the duration 1. C with the duration 1. So this is done. Next we have 3 to 4. So I have a node here 3. So this should go to 4 with the duration 1, and the name of the activity is D. So I have D with the duration 1. So next we have 3 to 5. So from 3 I should go to one more node which is 5, and its duration is 6, and name of the activity is E. So after 3 to 5 we have 4 to 9. So 4 to 9. This is another activity and it's F with the duration 5. So next we have 5 to 6. So 5 to 6 and the duration is 4, and the activity name is G. Next we have 5 to 7. 5 to 7, activity name is H and the duration is 8. So after 5 to 7 we have 6 to 8 and we have 7 to 8. So 6 to 8. So 8 is a node here. So activity name is I and the duration is 1. 7 to 8, again from 7 to 8, name of the activity is J and the duration is 2. So this is done. Next we have 8 to 10. So this is 8. From 8 I should go to a new node which is 10 with the activity K, and its duration is given as 5. So the last activity is 9 to 10 with the duration 7. So I have 9 here and 10 here. So I'll just join them with the activity L and its duration is 7. So this is construction of the network. So from the given question, we are done with the first requirement, constructing the network. Now let us start with forward pass computation. In this forward pass computation, we are going to obtain earliest starting time. So at every node, we are going to calculate the earliest starting time for that activity. So to start with, we are going to start with the node 1, which is the initial node of the network. So the initial node of the network will have the earliest starting time as 0 always. So after we identify it for node 1, let's move on to node 2. So to calculate earliest starting time for node 2, we are going to add the previous node's earliest starting time with the duration of the activity. So the previous node's earliest starting time is 0 and the activity A's total duration is 4. So 0 plus 4 will be 4, which is the earliest starting time for the node 2. So after 2, let's go to the node 3. So for this node 3, we have the tail event as 1. So for this 1, we have the earliest starting time as 0 and the activity between 1 and 3 is B and its duration is 1. So 0 plus 1 will be equal to 1, which is the early starting time for the node 3. So next, after 3, let's go to the event 4. So for this event 4, we have 2 previous nodes, correct? So we have 2 also as the tail event and we have 3 also as the tail event. So in this case, we are going to calculate in both the paths, and whichever value is maximum, that will be considered as the earliest starting time for 4. So if I take 2 to 4, so I have the earliest starting time as 4 and the duration is 1. So 4 plus 1 will be equal to 5. So if I take this path, the earliest starting time of 3 is 1. The project duration is 1. So 1 plus 1, it will be equal to 2. So among 5 and 2, as 5 is the biggest number, we are going to consider 5 as the earliest starting time for the node 4. So whenever we have a merged node, we have to take the maximum value possible from the previous nodes. So after 4, let's go to the node 5. So this node 5 has 3 as the previous node and its earliest start time is 1. So 1 plus 6 will be equal to 7. So earliest start time for the node 5 is equal to 7. After node 5, we'll go to node 6. So node 6 has the previous node as 5. 5 has the earliest starting time as 7. So 7 plus 4 will be equal to 11. So for node 7, it will be 7 plus 8, which will be equal to 15. So after 7, let's go to the node 8. So node 8 will have 2 options. So one option is 11 plus 1, which will be 12, and the other option is 15 plus 2, which will be 17. So among 12 and 17, 17 is the maximum value. So we will take 17. After 8, go to the node 9. So 9 has 5 plus 5, which will be equal to 10, and node 10, again it has 2 options. So first option is 10 plus 7, it will be 17. Second one is 17 plus 5, which will be 22. So among 17 and 22, 22 is maximum. So let's take 22 as the earliest starting time for the node 10. So this is called as the forward pass, where we get the earliest starting time for all the nodes. So after forward pass, let's continue with the backward pass. So backward pass is used to calculate the latest allowable time for all the events. So to calculate the latest available times, we have to start from the last node in the network. So the last node is node 10. So from this we will start calculating the latest allowable time, or we can also call it as the latest completion time. So for the last node, the earliest starting time will be the latest completion time. So earliest starting time is 22. So latest completion time will also be equal to 22. After 10, go to the node 9. So here the formula for calculating latest completion time is previous node's latest completion time minus the activity duration. So LC, I'll just mention this as J minus what is this? This is the time of the activity. I'll mention it as Tij. And here when you have dilemma, you are going to take the minimum of this values. So for 9, I don't have any dilemma. I just have to subtract 7 from 22. So 22 minus 7 will be equal to 15. So we will write 15 in this place. After node 9, let's go to node 8. So for node 8, we have 8 and 10 as the head and tail events. So here the event has 22. So 22 minus 5 will be equal to 17. So 17 is the latest completion time for the node 8. So let's mention it as LC here. So after 8, we'll go to 7. 7 is what? 7 and 8 are there for the activity J. So 8 has the latest completion time as 17. So 17 minus 2, which will be equal to 15, is the latest completion time for the node 7. So go to the node 6. So 6 has 17 as the previous node's latest completion time. 1 is the activity duration. So 17 minus 1, which will be equal to 16, is the latest completion time for event 6. So for 5, we have two options. So one option is 16 minus 4, which will be 12, or we have 15 minus 8, which will be 7. As I told you, when we have two options, we are going to take the minimum value among them. So 16 minus 4, 12, or 17 minus 8, 7. So 7 is the minimum value. So we are going to take the value 7 as the latest completion time for the node 5. So after 5, we'll go to 4. So 4 has 15 minus 5, which is equal to 10. So come to node 3. So node 3 again has two options. So this path, if I take, it's going to be 10 minus 1, 9. If I take this path, it's going to be 7 minus 6, 1. So 1 is the least. I will take the value as 1. So go to the node 2. So node 2 has 10 minus 1, which is equal to 9. So 9 is the latest completion time for node 2. So come to node 1. So for 1, again I have two options. So 1 will be 9 minus 4, 5, or I will have 1 minus 1, 0. So 0 is the minimum value. So we are going to consider 0 as the latest completion time for the event 1. So this was backward pass, where we got the latest allowable time for each and every node on the network. Okay, let's start with the next part of the question, which is identifying the critical path. To identify the critical path, first we have to identify the critical activities. So to identify the critical activities, we need to check with these following conditions. So the condition says, so the latest completion time should be equal to the earliest start time. Okay, so let's see. If I look at this first node, its latest completion time is 0 and earliest start time is also 0. That means LC of I is equal to the ES of I. So this node has this activity B, where the head node also is following the same condition. See, 1 equal to 1. So LC is equal to ES. So for this activity, to check whether it is critical activity or not, we have to check for these conditions. LC of I 0 should be equal to ES of I, which is equal to 0. Yes, this condition is true. Now look at this. This is considered as J node. LC of J is equal to ES of J, 1 equal to 1. Yes, this condition is also true. So the third condition is LC of I minus LC of J and ES of I minus ES of J should be equal to Tij. So what is LC of I? LC of I is 0 minus what is LC of J? It is 1. So it should be equal to ES of I is 0 minus ES of j is 1, and it should be equal to what? The time duration 1. Check with this condition. 0 minus 1, I have it as 1. Next we have 0 minus 1, again the difference is 1 and it is equal to 1. See, you might think it should be minus 1, here also it should be minus 1. But here we are just going to check the difference. So we are not going to consider the minus symbol here. So the difference is 1, here also the difference is 1, which should be equal to the activity duration. So this condition is satisfied. So I can say that the activity B is a critical activity. To identify that, you can just draw a bold line for this activity B. So after this, now keep checking the same condition on the further activities. See, for this node 5, I have LC as 7 and ES as 7. Now on this, check for these conditions. 7 equal to 7, 1 equal to 1, 1 minus 7 is 6, again 1 minus 7 is 6, and the event duration is 6. So this considers all three conditions. So this will be a critical activity. So similarly, I'll just draw the critical activities by checking the conditions. So this is a critical activity, 15 by 15. Next we have 17 by 17. This also follows also all the three conditions. So this is a critical activity. Next we have 22 by 22, 17 and 7. 17 and 22 difference is 5. 17 and 22 difference is 5. So this also falls good for the critical path condition. So this is also a critical activity. So after the completion, you can see we have the activities as B, E, H, J and K. So just write down them. So we are starting from the node 1 and we have the next node as 3, and next we have 5, next we have 7, next we have 8, and then we have the node 10. So between this we have the activity B, E, H, J and K. Write down their durations. So duration of B is 1, duration of E is 6, duration of H is 8, duration of J is 2 and duration of K is 5. So if I add all these durations, so 5 plus 2 7, 7 plus 8 15, 15 plus 6 21, 21 plus 1 22. So the total project duration is 22 days. So we have got this with the help of the critical path. Now let's move on to the last stage of the procedure, which is calculation of various floats. Floats are calculated to check the time fluctuations. Formulae for calculating different floats are given here. For an activity, tail node is considered as the ith node and the head node is considered as the jth node. So with respect to that, for the activity A, if I take example, 1 is the node I and 2 is the node j. So here in this formula, for every activity, j and I representations are given, where LC represents the latest completion and ES represents the earliest start, and TIJ, this will represent the duration of an activity. So based on this formula, we are going to calculate total float, and based on this we will calculate free float, and based on this we will calculate the independent floats. So now let us start with the calculation. Okay. So first we will calculate the total float for all the activities. So the activities are given here. So the first activity is 1 to 2. So that means we are considering the activity A, whose tail node is 1 and head node is 2. The formula is LC of j minus ES of I minus Tij. See, I have represented this formula in form of a picture also here. For every node we have ES and LC. So this is ith node and this is jth node. We are going to take the difference of LC of j and ES of I, and again we will subtract it with the activity duration. So let's see how to do it for this 1 to 2. So 1 to 2, if you take LC of j is 9. So 9 minus, what is ES of I? ES of I is 0. So 9 minus 0 and minus Tij. What is Tij of A? Tij of A is 4. So 9 minus 0 minus 4. So we will get this difference as 5. So we are done with the activity 1 to 2. So now let's go to the next activity 1 to 3. So this is I and this is j. So now let's go to the activity 1 to 3. So for 1 to 3, this is I and this is j. LC of j minus ES of I minus this, which is 1 minus 0 minus 1. So we will get the result as 0. So let's go to the activity 2 to 4. 2 to 4 is here. So LC is 10, ES is 4. 10 minus 4 minus 1. So we will get the result as 5. So after that we have the activity 3 to 4. So for 3 to 4 we have 10 minus 1 minus 1, which will be equal to 8. For 3 to 5 we have 7 minus 1 minus 6. So 7 minus 1, 6, 6 minus 6, which will be equal to 0. Similarly, we will calculate it for all the nodes and the values we will get will be 5, 5, 0, 5, 0, 0 and 5. So this is the calculation of the total float. So next let's move on to the free float. So free float will be calculated with this formula, where we are going to find the difference of earliest start time of the jth node and earliest start time of the ith node and minus the activity duration. So again we will start with the first activity 1 to 2. So for 1 to 2, this is the jth node and this is the ith node. ES of j is 4 minus, what is ES of I? ES of I is 0 minus, what we have to take? We have to take the activity duration, which is 4. So we will get the result as 4 minus 0 minus 4 as 0. So for the next activity 1 to 3, it is 1 minus 0 minus 1. So we will get it as 0. So 2 to 4, which is 5 minus 4 minus 1. We will get it as 0. Next for 3 to 4, 5 minus 1 minus 1. 5 minus 1 is 4, 4 minus 1 is 3. So similarly, using the formula, if I calculate, I will get the values as this: 5, 0, 0 and 5. So this is the calculation of free float, and we have done it with the help of this formula. So look at this pictorial representation. For I and jth node, we are going to find the difference of ES here and ES here, and we will subtract it with activity time Tij. So now let's go to the next type of float, which is independent float, and the formula is ES of j minus LC of I minus Tij. So for the ith node and the jth node, we are going to define the difference between latest completion of I and the earliest start of j. So earliest start of j is this and latest completion of I is this. Find their difference and then subtract it with Tij. Okay, let us start with the first activity 1, 2. For 1, 2, earliest start of j is 4 and latest completion of I is 0. So we will have it as 4 minus 0 minus 4. So the difference I will find here will be equal to 0. So similarly, using the same formula, if I calculate it for the rest of the nodes, I will get it as 0, 3, 3, 0, 5, 0, 0, 0, 0, 0 and 0. So this is the value for the independent float that we will get for this problem. So with this we have completed all the requirements of the problem. So first we constructed the network, we calculated earliest start time, we calculated latest completion time, we calculated the project duration, we identified the critical path, and now we have calculated various floats. So this is the solution for a CPM problem. So if you have any doubts, you can post me on the comments. Thank you.